All right, so for all those people that have been following along and paying attention this whole time, save that question for a minute, okay? So I will come back. So I will answer any questions you got at the end, okay? All right, so class.
Yes.
Ooh, thank you. All right, so derivative of a trigonometric function. So all those quotient and product rules that we were doing a little bit ago, okay, set those aside, okay, because this is something new. Now, when we do these, there is a madness to my method. It works every time because sine and cosine, if I were to graph them, what are they? It's a wave, right? And so it will move one onto the other. If I just phase shift it over, I could put a sine on a cosine if I phase shift it over. I could do that every single time. And so this is what you're going to do. So right now on your notes, you're not drawing a smiley face or whatever it is that you're currently drawing. So draw a circle. On the top, you're going to put sine. On the bottom, you're going to put negative sign. On the right, you're going to put cosine. On the left, you're going to put negative cosine. It's almost like there is something to do with this. There's always one thing in my circle where that one thing always works. If you guys look at your unit circle all the way to the top, what is on top? One where? Which one is one? Sine. Sine is one on the top. Okay? Now go to the right. On that unit circle, all the way at 0 radian, all the way to the right. Which one is one? Cosine. Okay. So cosine is 1 over there, right? Okay, all the way down. That would be negative pi over 2, or it would be 3 pi over 2, either way that we're going. It's a negative 1, isn't it? So sine is negative 1 down there. Okay, all the way to the left? Yeah, so negative 1. So cosine is negative 1 there, right? So what this is actually, this is what you're writing in here, ddx. So we are going to have the derivative. So the derivative of sine is going to give me cosine. So the derivative of cosine is going to give me negative sine. The derivative of negative sine is going to give me the derivative of negative cosine is going to give me this is almost the reason why I wanted you to stop drawing whatever it is you're drawing and actually draw this, because this is super important.
So that means the fourth derivative of sine is just sine?
Mm-hmm. Because it's a wave. Hmm?
Is it possible for it to go backwards?
Guess what that's called?
The
Antiderivative.
yeah.
Yeah.
Those are
Everything in math has its operator which will undo it. What is the opposite? What is the opposite of addition? What is the opposite of multiplication? So it will undo it, right? What is the opposite of a power? A root, right? Okay. What about a derivative is going to be an antiderivative? And everything in math has its something that it's going to undo what we just did. So everything that we're learning, you'll eventually learn something to undo that, to work it backwards too. So forwards and backwards. All right, let's go through. What is the derivative of x? 1. Okay, so this is y prime is going to be 1. And what's the derivative of sine? Cosine, but there's a 4 out front. For cosine, right? And am I changing the signs? No, I'm not changing the sign. So that plus sign stays a plus sign. The reason why I'm asking that is because sometimes when you take a derivative, like of cosine, it changes the sign because it becomes negative sine, right? So this is going to be plus 4 cosine x. This one right here, what rule is that? What's happening in between these two items? Product rule. Very good. Product rule. So product rule. Label what it is we're talking about. This is F. This is G. My F prime is going to be 2x. Very good. My G prime is going to be cosine. So I'm using the product rule, and so it's F prime G. So 2x times G, which is sine x, plus G prime, which is cosine x, times F, which is x squared. All right, I'm going to put it together, but since it's a sine here and a cosine here, I can't do much except for just rewrite it as 2x sine x plus x squared cosine x. Yeah.
Where did you get the x squared from?
Because this is going to be f prime times g plus g prime times f. And that's why I said it's important at the very beginning when you're doing these problems, label everything that we're going to do, and then we can just plug in and use the formula. All right, you guys ready for C now? Okay. All right, sine x over x. I'm gonna make a new page here. All right, what type of problem is this? What's happening to those two things? Dividing, and what is that called? Quotient rule. That's quotient rule. So I know a lot of people have problem with this because I assigned the notes on a day that I wasn't here, and I asked you guys to do just one set of problems. And I got like one view on that. And I'm pretty sure everyone in the class didn't watch the same one. So, and all you had to do was just this one quotient problem. That's it. Now, let's go through and do the quotient rule here. The same thing, so it's f prime is going to be the derivative of sine is g prime is, there we go. So my formula for this, is that it? 2.5? There's the one up there. Now, if you're looking only at the notes and you didn't watch the video to go along with this, I changed the order. Now it's the same order as what we did on the quotient rule, or I'm sorry, in the product rule. So f prime g, g prime f. But in the notes, or in the formulas, they put these backwards. I don't like that. I don't like changing it. I know that quotient should be a minus. Product should be a plus. So as you're going through, try to remember those. It's the same order. It's just right here, quotient is a minus over g squared. So f prime is going to be cosine x times g, which is 1, minus g prime, oh wait, not g, g is x. Sorry. My fat head's in the way. Minus g prime, which is 1, times f, which is sine x, all over g squared, x squared. And I just need to clean it up. X cosine x minus sine x all over x squared. And to finish out is called my y prime. And back one, e to the x times sine x. So f, g, so what rule am I using on this? Yep, product rule, because they're multiplying. F prime was the derivative of e to the x, e to the x. And g prime, the derivative of sine, cosine x. Very good. So product rule. So f prime, e to the x times g sine x plus g prime cosine x times f e to the x. So I'm going to have e to the x sine x plus e to the x cosine x. And there's one last thing, especially these type of problems. Do they have a common factor? Because quite often when you do these problems right here, you're normally going to have to do a second or a third derivative. Bless you. A second or third derivative off of it. So to make your life easier, because right now I have two products. This one here is a product. This one here is also a product, isn't it? since they're both products, do you want to do product rule twice? Say no. Can I factor something out? Do they have a common factor? Yes, I'm going to take that out. So that's going to be e to the x times quantity sine x plus cosine x. Now, if I were to take the second derivative of this, I could just do this, and using one product rule, it would still work. So I'm trying to save myself a lot of headache later on. Is that okay? Questions over this? All right, let's see, that's that one. And so you guys already have this, because didn't we do this one on the circle? We know that the derivative of cosine gives me negative sine, because that's why we drew the circle. We already have those. Now, I'm going to pick up on these tomorrow. I promised you guys I would give you guys time at the end here to actually ask some more homework questions. So make sure you all like, share, and subscribe. Hit that notification button and buy something from my merch store, because I'm a poor teacher.